Welcome to Fun with RFCs, where I try to take really dry technical writing and make it exciting by using bad jokes and adding images, not to mention a variety of comments that are either factual, opinionated, or irrelevant. Today's RFC is 1918, aka Address Allocation for Private Internets. This RFC made 1627 and 1597 obsolete. Here are the authors. We got somebody from Cisco Systems, the Chrysler Corporation, G.J. de Groot. I have no idea who that is, though I do know who Groot is from Guardians of the Galaxy. And the organization he is with is RIPE NCC. That actually comes later in the RFC, so you'll know what RIPE means a little later on. And then we have somebody from Silicon Graphics Inc. And this apparently was published in 1996. That was a pretty good year. Here in Colorado, we had a blizzard, and I got to stay out of school for a whole week because of that, if I remember correctly. So I'll just basically read to you here. You can follow along to improve your reading skills or not. This document specifies an Internet best practices for the Internet community and requests discussion and suggestions for improvements. Distributions of this memo is unlimited. So introduction. For the purpose of this document, an enterprise is an entity autonomously operating a network using TCP/IP, and in particular, determining the addressing plan and address assignments within that network. So what I'm thinking is this is key right here. Homeowners typically are not creating an address or a plan / assignment for the address at their house. So that is something pretty curious. That's why I like RFCs, because they talk about things people might just take for granted, like how is it determined what address who gets? Like what's the plan so that we have some sort of order to these assignments? And of course, since it mentions enterprise, they're talking about business, not the Starship Enterprise. This document describes address allocation for private internets. The allocation permits full network layer connectivity among all hosts inside an enterprise, as well as among all public hosts of different enterprises. The cost of using private internet address space is the potentially costly effort to renumber hosts and networks between public and private. So when I say private internets, I'm typically referring to a company that would want to have a network or a connection in their building that is private and just for them and their employees to use. Again, you're seeing this word enterprise, and to really wrap your mind around the difference between an enterprise and a home network, I suggest you listen to a podcast called This Week in Tech, This Week in Enterprise Tech, because Lou Maresca here does a great job going over all tech related to business. So the motivation. With the proliferation of TCP/IP technology worldwide, including outside the internet itself, an increasing number of non-connected enterprises use this technology and its addressing capabilities for sole intra-enterprise communications without any intention to ever directly connect to other enterprises or the internet itself. So if you're a business, you could connect to the internet, or you could not and still do a lot of networking things in your company. And I like how this RFC is pointing out the intention of this whole address allocation process. So the intention is to give businesses options in terms of network. So my picture for this one is a little lower here. 6 signs a nice person secretly has negative intentions. Like, that's all well and good to have intentions. One of my favorite quotes is, the road to hell is paved with good intentions. But if you're a business and you intend to just have a private network, I completely respect that. What I'm thinking, I say here, at least you'll be secure. Though despite intention, someone might ruin this. Can an attacker get in if someone connects to a hotspot? All it takes is one connection, right? One person who, despite the company's wishes, connects to the internet. And now they've created an open portal for the bad guys to get in. So intentions is one thing, actions are another. That's all I'm trying to point out right here. The internet has grown beyond anyone's expectations. Yes, that is very true. Sustained exponential growth continues to introduce new challenges. One challenge is a concern within the community that globally unique address space will be exhausted. And a separate and far more pressing concern is that the amount of routing overhead will grow beyond the capabilities of internet service providers. Efforts are in progress within the community to find long-term solutions to both of these problems. Meanwhile, it is necessary to revisit address allocation procedures and their impact on the internet routing system. To contain growth of routing overhead, an internet provider obtains a block of address space from an address registry and then assigns to its customers addresses from within that block based on each customer requirement. The result of this process is that routes to many customers will be aggregated together and will appear to other providers as a single route. Read RFC 1518 and 1519. In order for the route aggregation to be effective, and what is route aggregation? This is an alternative term for route summarization, which is a method to use to minimize the number of routing tables required in an IP network. So that does make sense. Basically, route aggregation is designed to lower the number of routing tables in a network. So in order for route aggregation to be effective, internet providers encourage customers joining their network to use the provider's block and thus renumber their computers. Such encouragement may become a requirement in the future. And I know for the ISP, at least in my city, if I want a static IP address, I have to actually pay extra for it. But they are giving me that option. So thus, they may encourage me to not have a static IP. They certainly will let me. And if you want to learn more about route aggregation, Professor Miser has great videos on YouTube. With the current size of the internet and its growth rate, it is no longer realistic to assume that by virtue of acquiring globally unique IP addresses out of an internet registry, an organization that requires or that acquires such addresses would have internet-wide IP connectivity once the organization gets connected to the internet. To the contrary, it is quite likely that when the organization would connect to the internet to achieve internet-wide IP connectivity, the organization would need to change the IP addresses, aka renumber, all of its public hosts that require internet-wide IP connectivity, regardless of whether the addresses used by the organizations initially were globally unique or not. So not a good thing, right? We don't want people needing to renumber. In terms of this globally unique IP address, I said, are they, that is, computers within the organization, getting kicked off the network more frequently? So what means harder? Like, maybe we'll find out in RFC 1466? Which, by the way, I'll do immediately after this one. All right, so we're a quarter way done. Hopefully you're not asleep yet. It has been typical to assign globally unique addresses to all hosts that use TCP/IP in order to extend the life of the IPv4 address space. Address registries are requiring more justification than ever before, making it harder for organizations to acquire additional space. Read RFC 1466. So this word harder really stuck out to me. I'm wondering how. How can they make it harder for an organization to acquire additional space? Is there a group out there, maybe a group of people saying, no, you cannot have any more addresses? Watch the next episode and I will go over RFC 1466 to let you know what I find out. Hosts within enterprises that use IP can be partitioned into 3 categories. Category 1, and over here I'm saying Category 1 is like the lone wolf of the categories. Hosts that do not require access to hosts in other enterprises or the internet at large. Hosts within this category may use IP addresses that are unambiguous within an enterprise, but may be ambiguous between other enterprises. So what does ambiguous mean? That is open to more than one interpretation, aka having a double meaning. So in the lone wolf category here, you can have an IP address that is the exact same IP address of another host, of another computer somewhere else, but it's not a problem because it's in category 1. There's not going to be an IP address conflict because these computers are just off on their own little network away from the rest of the internet. Category 2. hosts that need access to a limited set of outside services, for example, email, FTP, net news, remote login. Anyways, to a limited set of outside services which can be handled by mediating gateways. Remember, gateways are routers. For example, an application layer gateway. That would be at layer 7, the highest layer. Kind of funky for a gateway to be that high, but that's okay. So for many hosts in this category, an unrestricted external access provided via IP connectivity may be unnecessary and even undesirable for privacy and security reasons. Just like hosts within the first category, such hosts may use IP addresses that are unambiguous within an enterprise, but may be ambiguous between enterprises. So basically, category 2 is the in-between of category 1 and 3, which makes sense, right? And let me say this about application layer gateways. Normally, gateways or routers are on layer 3. I told you, layer 7, right? So normally they're on layer 3, and that's called the network layer. This layer is known as the layer where routing takes place. A router's main job is to get packets from one network to another. Notice I said one network to another network. If category 1 is just its own little network that's not going to connect to the internet or other networks, then that makes a lot more sense why it's layer 7 and not layer 3. Layer 3 protocols and technologies allow for network-to-network communications. So now that I'm thinking about application layer gateways, I had to dig deeper. ALG is how Wikipedia abbreviates it. So application layer gateways consist of a security component that augments a firewall or NAT, NAT being network address translation. That's where I'm sitting at home and I want to go on the internet, so I request the internet from my router. My router says this is his IP number. The internet, the web server, gives my router the data I'm looking for, and then once that data's there, the network address translation occurs, where instead of sending it directly to me, it has to find what IP address I am at on the inside and then send it to that IP address. Just Google image network address translation and everything I just said would probably become much clearer. So it allows customized NAT traversal filters to be plugged into the gateway to support address and port translation. For certain application layer, that is control/data protocols such as FTP, SIP, file transfer in IM applications, IM being like messaging. These are all reasons to use an application level gateway. So let's finish up with category 3, hosts that need network layer access outside the enterprise, that is, provided via IP connectivity. Okay, again, of course. Hosts in the last category require IP addresses that are globally unambiguous. That makes sense. So anytime I see the word unambiguous, I'm just going to see the word unique instead. And that makes sense to me. The IP must be globally unique if you're in category 3. So we will refer to the hosts in the first and second categories as private. We will refer to the hosts in the third category as public. Very logical. Moving on, many applications require connectivity only within one enterprise and do not need external outside the enterprise connectivity for the majority of internal hosts. In larger enterprises, it is often easy to identify a substantial number of hosts using TCP/IP that do not need network layer connectivity outside the enterprise. Some examples where external connectivity might not be required are a large airport, which has its arrival-departure displays individually addressable via TCP/IP. It is very unlikely that these displays need to be directly accessible from other networks. So it makes sense to me that the only way to change an airplane's arrival or departure display is if you're in some sort of like control room, control center, and you've been given that communication directly from a pilot or a manager or something, and then only in that one room with that one wire can you change the displays. Okay, another example where external connectivity might not be required. Large organizations like banks and retail chains are switching to TCP/IP for their internal communication. Large numbers of local workstations like cash registers, money machines, and equipment at clerical positions rarely need to have such connectivity. Another example, for security reasons, many enterprises use application layer gateways to connect their internal network to the internet. The internal network usually does not have access to the internet, Thus, only one or more gateways are visible from the internet. In this case, the internal network can use non-unique IP address numbers, non-unique IP network numbers. Geez, I'm just so used to saying the word address after the word IP. Interfaces of routers on an internal network usually do not need to be directly accessible from outside the enterprise. And many of you at home, if you've accessed the interface of your router, you probably saw something like this, and you usually do it from within a browser. Okay, page 3. Looks like we're almost halfway done here. The Internet Assigned Numbers Authority, IANA, has reserved the following 3 blocks of the IP address space for private internets, and I'll let you read that there. We will refer to the first block as a 24-bit block, the second as a 20-bit block, and to the third as a 16-bit block. Note that in preceder notation, the first block is nothing but a single Class A network number, while the network block is a set of 16 contiguous Class B network numbers, and the third block is a set of 256 contiguous Class C network numbers. At first I thought this was a typo, but the word contiguous means sharing or touching a border. So for example, there are 48 states in America that are contiguous states. Alaska and Hawaii don't actually touch the other 48. And by the way, part of the reason I'm doing this fun with RFCs is because I see more unique words in these RFCs that I just don't see anywhere else, and I think it's really fun to try to break them down and pull the meaning from them in the context of these technical documents. So, an enterprise that decides to use IP addresses out of the address space defined in this document can do so without any coordination with IANA or an internet registry. So notice there's IANA and then there are internet registries. When I went to Google IANA, which we can look above here what that word meant, it's the Internet Assigned Numbers Authority. So it's a group of people who are the authority of assigning numbers. Well, so are other internet registries, so there's more than one IANA. And apparently, IANA is also the name of a model who was murdered. So when I was Googling around trying to learn about this organization, I found that interesting fact out. And the fact that I'm talking to you about IANA controlling address space and talking about private IPs and whatnot, if you're a person who's about to take the A+ cert, these are things you've probably heard about in your studies, especially the concept of Class A, Class B, and Class C network numbers. So back to the rating. The address space can thus be used by many enterprises. Addresses within this private address space will only be unique within the enterprise, or the set of enterprises which choose to cooperate over this space so that they may communicate with each other in their own private internet. As before, any enterprise that needs globally unique address space is required to obtain such addresses from an internet registry, whether it's IANA or another one. And I don't know if that's even how you should say that word. Maybe people say IANA, but I just like using that name. Forgive me if I'm making some sort of faux pas here. So an enterprise that requests IP addresses for its external connectivity will never be assigned addresses from the blocks defined above, and that makes sense if we're going to have an organized internet here. But I do wonder what happens when you try to go against what you're being told. What happens if you try to force the issue? Do you just get weak connections? Is there the internet police somewhere coming after me for doing that or constantly trying to do that? That would be a fun research topic here. But let me try to finish up the reading here. In order to use private address space, an enterprise needs to determine which hosts do not need to have a network layer connectivity outside the enterprise in the foreseeable future and thus could be classified as private. So if you don't think your company's going to need to be on the internet, let's go ahead and just create a private network for you so you're not just taking numbers up needlessly. Such hosts will use the private address space defined above. Private hosts can communicate with all other hosts inside the enterprise, both public and private. However, they cannot have IP connectivity to any host outside of the enterprise. While not having external, outside of the enterprise IP connectivity, private hosts can still have access to external services via mediating gateways, such as the application layer gateways. So remember, those application layer gateways are at the very top of the OSI model. They are inside this network, and just through the application layer, they're making sure the right computers are talking to each other. Moving a host from private to public, or vice versa, though, involves a change of IP address, changes to the appropriate DNS entries, and changes to configuration files on other hosts that reference the host by IP address. Lots of changes, right? So to summarize, if you're going to be a company that wants a private internet, you should be sure, because if you change your mind, you're going to need to first change the IP, that's obvious. Then you'll need to change DNS configurations, then change configuration files on other computers that reference that computer that you once disallowed from the internet. Okay, because private addresses have no global meaning, routing information about private networks shall not be propagated on enterprise links, and packets with private source or destination addresses should not be forwarded across such links. Routers in networks not using private address space, that's especially those of internet service providers, are expected to be configured to reject, filter out routing information about private networks. Oh, maybe that answers my question from above, like what happens if you try to just go against the grain and ignore these internet registries and IANA? Well, maybe at the end of the day, the routers are just going to reject you. If such router receives such information, the rejection shall not be treated as a routing protocol error. Indirect references to such addresses should be continued within the enterprise. Prominent examples of such references are DNS resource records and other information referring to internal private addresses. In particular, internet service providers should take measures to prevent such leakage. What a crazy concept. Internet leakage kind of made me think about Ghostbusters there. Especially Ghostbusters 2, when you have that pink goo leaking from the sewers. So part 4, advantages and disadvantages of using private address space. The obvious advantage of using private address space for the internet at large is to conserve the globally unique address space by not using it where global uniqueness is not required. So that paragraph just sounds like a lesson in etiquette. Enterprises themselves also enjoy a number of benefits from their usage of private address space. They gain a lot of flexibility in network design by having more address space at their disposal than they could obtain from the globally unique pool. So that makes a lot of sense too. If you section yourself off, you're going to have so many more options than if you were to join the group being the internet in this analogy. What the RFC says is this enables operationally and administratively convenient addressing schemes, as well as easier growth paths. And that got me to wonder, are there some examples of large corporations using or utilizing this private address space to the max? Like, what's the largest corporation out there with the largest private network? How many IPs are they actually using inside that place? And it can be like inside that network. It doesn't have to be a physical place. Anyways, for a variety of reasons, the internet has already encountered situations where an enterprise that has not been connected to the internet had used IP address space for its hosts without getting this space assigned from IANA. In some cases, this address space had been already assigned to other enterprises, and if such an enterprise would later connect to the internet, this could potentially create very serious problems, as IP routing cannot provide correct operations in presence of ambiguous addressing. Although in principle, internet service providers should guard against such mistakes through the use of route filters. So it sounds like everything is on the shoulders of the ISPs here. This does not always happen in practice. Using private address space provides a safe choice for such enterprise, avoiding clashes once outside connectivity is needed. And if I had the time, I would have wrote on Homer Simpson's shirt here like ISP. I'm sure the ISPs will want to strangle the enterprises that claim to be private but then later change their mind and try to get on the network, and then you have those IP address conflicts. Okay, a major drawback to the use of private address space is that it may actually reduce an enterprise's flexibility to access the internet. Once one commits to using a private address, one is committing to renumber part or all of the enterprise. Should one decide to provide IP connectivity between that part or all of the enterprise and the internet. So usually the cost of renumbering can be measured by counting the number of hosts that have to transition from private to public. As was discussed earlier, however, even if a network uses globally unique addresses, it may still have to renumber in order to acquire internet-wide IP connectivity. So I don't know why it has to renumber. And then the first half of this paragraph makes a lot of sense. That's kind of just common sense writing right there. If you have to renumber, that sounds like it's going to be a big problem. It sounds like RFC 1918 here is all about having a private network and trying to avoid renumbering. Because what I'm thinking is the day that happens, the router is going to get overtime pay. It's probably a lot of IP addresses that need new numbers. So another drawback to the use of private address space is that it may require renumbering when merging several private internets. Okay, so sometimes RFCs can be really redundant. Maybe that would be my comment if they're requesting my comment is don't be redundant. I maybe suppose these RFCs aren't written by people who are novelists, but people who are experts at writing technical documents, so they're going to cover every base for sure. And I highlighted in red right here that companies tend to merge. We see that in business news all the time, or if you watch the stock market and you watch what happens when one company buys another company, AT&T and Time Warner. If such companies prior to the merge maintain their uncoordinated internets using private address space, then if after the merge these private internets would be combined into a single private internet, some addresses within the combined private internet may not be unique. As a result, hosts with these addresses would need to be renumbered. The cost of renumbering may well be mitigated by development and deployment of tools that facilitate renumbering. So you're telling me I can make it easy on myself. One example they're giving here is DHCP, and a fascinating thing I'd found is a lot of routers, when you buy them, they have a DHCP server built into them. When deciding whether to use private addresses, we recommend to inquire computer and software vendors about availability of such tools. A separate IETF effort, IETF Internet Engineering Task Force, is pursuing full documentation of the requirements and procedures for renumbering. So if I'm doing these Fun with RFCs series, I wonder if anybody would want me to do a Fun with IETFs documentation series. I don't even know what those look like yet, so maybe I'll look into that. Okay, part 5 here, operational considerations. One possible strategy is to design the private part of the network first and use private address space for all internal links. Then plan public subnets at the locations needed and design the external connectivity. This design does not need to be fixed permanently. If a group of one or more hosts required to change their status from private to public, later this can be accomplished by renumbering only the hosts involved. Oh my goodness, so redundant here. Let me jump down. Here's the class A, B, and C we were talking about earlier. If you're going to take your Networking Plus test, you might need that. Same with the other certifications in networking. You'll soon learn class A, B, and C like the back of your hand. If a suitable subnetting scheme can be designed and is supported by the equipment concerned, it is advisable to use the 24-bit block, aka the Class A network, of private address space and make an addressing plan with a good growth path. If subnetting is a problem, the 16-bit block or the 20-bit block of private address space can be used. One might be tempted to give or have both public and private addresses on the same physical medium. While this is possible, there are many pitfalls to such a design. Note that the pitfalls have nothing to do with the use of private addresses, but are due to the presence of multiple IP subnets on a common data link subnetwork. We advise caution when proceeding in this area. It is strongly recommended that routers which connect enterprises to external networks are set up with appropriate packet and routing filters at both ends of the link in order to prevent packet and routing information leakage. So if you were wondering earlier about leakage and how to stop it, there you go. An enterprise should also filter any private networks from inbound routing information in order to protect itself from ambiguous routing situations which can occur if routes to the private address space point outside the enterprise. So this image is perfect for the way my mind works. And if we're talking about inbound routing information, I'm thinking inbound missile attacks. But here in our bubble, in our private network, an enterprise should filter any private networks from such inbound routing information. That makes sense. So it is possible for two sites who both coordinate their private address space to communicate with each other over a public network. To do so, they must use some method of encapsulation, I love that word, at their borders to a public network, thus keeping their private address private. If two or more organizations follow the address allocation specification, I just thought that word would be specification. If two or more organizations follow the address allocation specified in this document, and then later wish to establish IP connectivity with each other, then there is a risk that address uniqueness would be violated. To minimize the risk, it is strongly recommended that an organization using private IP addresses choose randomly from the reserved pool of private addresses when allocating subblocks for its internal allocation. I imagine a really good networking engineer would know how to set up this pool. I asked the question, where would I find this pool if I was to just audit maybe a network in some business or walk in and ask for some insight on this RFC 1918? If an enterprise uses the private address space or a mix of private and public address space, then DNS clients outside of the enterprise should not see addresses in the private space being used by the enterprise, since these addresses would be ambiguous. So one way to ensure this is to run two authority servers for each DNS zone, containing both publicly and privately addressed hosts. One server would be visible from the private address space and would contain only the subset of the enterprise's addresses which were reachable using public addresses. The other server would be reachable only from the private network and would contain the full set of data, including the private addresses and whatever public addresses are reachable. In order to ensure consistency, both servers should be configured from the same data, of which the publicly visible zone only contains a filtered version. There's a certain degree of additional complexity associated with providing these capabilities. So in conclusion, you know what? Let me just read what's in red. This is the money maker right here. However, use of private addressing requires that an organization renumber part or all of its enterprise network as its connectivity or requirements change over time. So if you can accurately predict the future, you can accurately address your network. That's what I'm getting out of that last sentence. Thank you for learning with me, and I look forward to any comments you may have about what I'm doing here. This is a brand new thing for me, so I know it's a little crazy, but I do have fun creating these.